Hello, I'm Daniel, a hardware engineer at Droid Technologies. I specialize in designing both digital and analog devices. My responsibilities include schematic and PCB design, signal verification, prototype testing, and preparing the hardware for certification and mass production. In this video, I would like to demonstrate a custom-built piezo sensor designed to capture the sound of the heart and lungs. This construction consists of a piezo film, a preamplifier, an amplifier, and an analog-to-digital converter. Piezo film is based on the piezo effect. Basically, when you make a mechanical deformation, for example, connect to some vibration source, it changes the electromagnetic field under the small deformation. On output, we have a microvolts to millivolt signal that is possible to amplify and convert to digital by ADC. Let's take out the custom PCB that has a preamplifier and amplifier and connect to the ADC chip with USB output for the test. For a better picture, let's look at the analog part of the schematic. And we see next. We have two analog inputs that we connect to a piezo sensor as a diff signal. And additionally, we have a shielding and connect the third contact to the ground. These inputs connect to two charge preamplifiers, which accumulate and amplify the charge from the piezo sensor. Signals come into a diff voltage amplifier and then filters by operation amplifiers. On output, we have amplified and filtered an analog signal, which we could connect to a USB audio card for the test. There are a few issues that we faced. External noise that had to be filtered at different frequencies, for example 50 Hz from AC. A rather complex mechanical structure that was highly sensitive to damage of the sensor film. Poor performance of the signal extractor. We experimented extensively with materials and mechanical design to improve sensitivity and amplification. Let's connect our sensor to a USB audio card with an ADC and use Audacity to observe the signal. Let's record a signal and repeat. As we see, it works well. Designing an analog sensor that operates at low voltages, minimizes noise, and incorporates advanced mechanical construction is a complex and demanding process. At Droid Technologies, we're here to assist you with your embedded design projects, covering electronics, firmware, software, and mechanical design to ensure successful implementation and optimal results.